Welcome everyone to tutorial 1038, Automate Your Edge. My name is Don Vosberg. I'm product manager for SUSE Manager. I'm based in Indiana in North America. And my co-presenter is...
I'm Cedric Bosdona, a senior software engineer in the SUSE Manager team, and I'm based in France.
Thanks, Cedric. So what are we going to be talking about in this session? First of all, why do you want to automate your edge this way? It's always good to know why whenever you're uh, discussing a topic. And then secondly, we'll give you the guts of all the different bricks that are part of this solution, explaining how we chose them and what they are, and then we'll show how the workflow happens. And then Cedric will be presenting a demo of this solution for you. So off we go. Why automate your edge this way? So first of all, many people will have what's called a hybrid edge, where some of your applications are running on top of containers and require Kubernetes or some type of container management. And you, at the same time, you may also have traditional applications that run on virtual machines or on servers or point of service devices out at the edge. And you have to scale too many. So typically, people who are doing edge deployments don't just have one single place where that happens, but many of them. And in order to do that right, you kind of want them to look the same and have consistency. Be able to do that with automation means you don't have to fly there to the remote site to do this. You can push it out and watch it happen in a predictable and manageable way. So, doing that in a hybrid edge is a real challenge. So, what we are proposing here is that we can give you proxy cache for those virtual workloads for images, repositories, configurations, the things that are going to make it consistent. And we can we can do that on top of Kubernetes. So here we're showing how we integrate with strategic cloud native infrastructure to make this scalable and in a hybrid way be able to do this uh, both now and in the future when you have additional cloud native applications. And finally, secure hardware deployment. So, as a part of our security messaging that you've heard a lot about maybe at this SUSECon, is that it's important to know that when I deploy it, I have used secure keys, delivered in a secure way. My operating system has TPM or whatever security elements that guarantee that it gets done in the right and secure way. So, next up.
And we'll see also that even if the hardware gets lost or stolen, you can still work this around and to avoid this stolen hardware to connect to the cluster when you don't have control in it.
Right, right. It keeps you secure in the case of lost things, which can happen out at the edge. SUSE has an edge solution. So SUSE Edge has several key components, and we're going to make use of all of them in this demonstration in this world. It can be applied to a lot of different use cases, whether it's retail, automotive, or telco. Those are some common ways that the edge is used, but you may have your own use case. So these three elements tie together very closely. SUSE Rancher Fleet, which you will see more about in a minute, That's the Kubernetes management piece. K3s is the simplified edge type CNCF distribution for Kubernetes. And Elemental is a minimalist operating system whose integrated deployment works alongside of these other two elements. So this is the base edge solution for cloud native. And what we've done in this demonstration is show it integrating with SUSE Manager, which is a traditional workload manager for a hybrid environment. So we'll have the presence of a SUSE Manager SUSE server is assumed in this demo, but we're deploying the proxy that moves the content closer to where it's going to be consumed. So these are the components that we're going to be using in this solution.
So now we'll see how these bricks are assembled together. First, what we have, as Don mentioned, we have Rancher Manager and Fleet. We have Elemental, which is the simplistic super minimal OS. We have K3s, which is this minimalistic Kubernetes distribution. We have SUSE Manager. In the demo, you will see it is Uyuni, but Uyuni is the upstream for SUSE Manager, so basically it's the same thing. So this will be managing the workloads, the traditional workloads in the edge, and the proxy. So the SUSE Manager or Uyuni proxy is a tiny caching thing that is avoiding to have constant communication between the edge side and the server. And this is the thing that we want to deploy automatically.
Right. So in this scenario, the proxy is the application, right?
Yes. The proxy is the application that will help you manage other workloads. So one of the most important basic building bricks is Rancher management. So it easily helps you manage multiple clusters in one single UI. It can handle all Kubernetes distributions, so just equally. We will manage K3s, but you can use it to manage other distributions as well for other purposes.
Yes, and Rancher can be a data center manager. In this case, we're applying it at the edge, but it can go across your Kubernetes deployment. And that is the value in managing Kubernetes, not just the versions of your cluster, but understanding what that infrastructure's health is. And you'll see in Cedric's demo a deployment using Fleet.
and here in the use case we have, you will see that we have one Rancher Manager that will manage all multiple Kubernetes clusters for each of our edge locations. And well, it's obvious to us, but Rancher is open source, is open to the core. One part of Rancher Manager is Fleet. It's called in the user interface. It's called. Oh, I can't remember. We'll see that in the demo. But there is one menu in there that will allow you to run a multiple Helm charts or Kubernetes YAML definitions, or customize, or a mix of these into an order you want, with potentially some customization for some clusters. And it will all read this from a Git repo. And every time you update to this Git repo, it will check the changes and apply them where needed. So it really goes into the Git ops, and all the cluster workload definition is just in a Git repo. Elemental. So Elemental is also something that you will see in the user interface. It's called OS management in the user interface. And it's also composed of a SLI micro based image. In this image will be available as an ISO image where you have a configuration file, and this configuration file will tell the hardware how to call home to the cluster and deploy everything.
So all of that security and authentication is wrapped into that ISO file, right?
Yes, and Elemental requires a TPM device to work. Um, and the idea there is that Elemental will expose some hardware data to the rancher part of Elemental, and so you can have the serial number or machine ID or whatever that is defined on the hardware. You can have it in the rancher manager, and there you can filter out which machine you want to apply what cluster on.
So it's basically a bridge between bare metal and Kubernetes in this environment, right?
Yes, because Elemental, when it first boots, we'll see that later in the demo, but it deploys the tiny image and then reboots and phones home to get the cluster. But well, let's not stay too long here because we'll see that later in the demo. K3s, so we already mentioned it, is Kubernetes stripped to the bones, very minimal. It's just a single binary that runs on the machine. It was a Rancher Labs project and has been donated to the CNCF.
That's the Cloud Native Compute Foundation. Is that right?
Yes, that's it. Thanks for reminding because we used to use those acronyms, but
Yeah.
the SUSE Manager Proxy. So this is the application we want to deploy here. It basically caches the packages, the images to install on the systems, and it relays everything to the server. So
And in an edge environment where you may have restricted or limited bandwidth, SUSE Manager Proxy's cache helps to bridge that and mitigate that bandwidth differentiation so that the clients only need to connect to the proxy. The proxy is the only thing talking to the SUSE Manager server.
yes.
Oh, if you can go back there one more time, my friend.
Oh, sure.
Yeah, so the interesting part about SUSE Manager Proxy, for those of you who may be familiar with SUSE Manager, in the past it was only delivered as a virtual machine. And
Oh, right. I
now,
forgot about this.
since SUSE Manager 4.3, we've been delivering it in containers. So we turned it into a cloud native friendly app with multiple containers, allowing you the capability to do this type of deployment for a proxy where that wouldn't have been possible with a VM. So we've essentially given you that bridge for a hybrid environment between the world of containers and the world of VMs.
Right. Thanks for reminding. I'm just living with it every day and totally forgot that it's new. So, how does it all works? So Rancher Manager server has to be set up obviously first, so we'll not cover this here. In the demo, we'll have a single node RK2 cluster, but anyone can do the work. Um, Elemental extension and operator need to be enabled and added to this cluster. It's not by default. There's nothing to do for fleet. It's all available once you have done that. Keys and certificates needs to be properly handled. In the demo here, we just use the default self-signed certificates, but just working nice. Then we'll need to define an endpoint on Elemental. In the demo, you will see that it is already defined because we already used it, and we tried to make it generic enough so that there's only one endpoint for all the edge locations, and everything is configured after in the cluster definition. So this is one of the good things that you can do with Elemental and Fleet, is that you can have some cluster labels that will be used as variables in the Fleet definitions, and then you can adjust the what is done by Fleet depending on these variables. So
And one of those is like the branch location or store location, right?
yes, the proxy IP or FQDN or whatever. And so we will generate an ISO image with this registration data, which is what will allow the newly bootstrapped Elemental VM to phone home and get to know what it has to deploy. And then it will deploy the cluster. And once the cluster is up and running, Fleet will discover, hey, I have a cluster. I need to apply they call it bundles on it, and it will just apply them sequentially.
And the end result is
A working
is
proxy.
proxy where you can register clients and do all the Suma things. So
Yeah.
now the demo.
Now it's time for demo. So we start here with a store, just a retail company with that has already a store 1234 registered. You see it, the proxy deployed, proxy cluster deployed in Rancher Manager, and the proxy is also registered in Uni for now. Now we want to create a new store for store 5678. So we will need to create the proxy configuration for it. Is the video is running, but maybe I didn't cut enough of it. So yeah, we'll create a proxy configuration here, and then we'll type the FQDN of the proxy, store 5678-proxy.wildcode.com. The parent FQDN is the FQDN of the Uni server itself. The squid cache size needs to be very carefully adjusted because this is depending on what repositories you want to be available on the systems, and if you have it too short, you'll you will not get all the goodness. So we had the table downloaded, and now we unpacked it. So it's a configuration table. The config.yaml file is generic enough, so it's already inside the Git repo here. And we need to get the httpd.yaml and the ssh.yaml files in our Git repo because these are specific to the new location. And since these contain security sensitive data, we need to encrypt them because Git is not secure repository, and we do this with sealed secret. So we seal the secret, and the encrypted data are stored in the Git repo. Now we are committing the secrets data on the Git repo.
If you're using a template, you would clone this Git repo to your own place and get, right?
Yeah, right. And then I pushed the repo. So now we can see the definition for Rancher and Elemental. So we have a machine selector at the top here, and you see the Pixie 5678-1 value here. This is a serial number that I defined in my virtual machine, and it will be matched at by Rancher to figure out, oh, this machine needs to be part of this cluster. So now we need to apply this definition. So the definition is added, and we already see the cluster here, but there's nothing here. It's just an empty cluster. We need to create the machines. So here I'm starting the virtual machine, the first one, the number one. Oh yeah, I wanted to reduce the memory a little bit to just and we have a TPM device here. We also have the serial number that is provided, and we provide also the ISO image. You see the elemental teal ISO image. Now we have the first boot, and during the first boot, Elemental will deploy itself on the blank disk of the hardware. Once this is done, it will reboot here, and then reach out to Elemental and say, hey, now the cluster is associated, and it will start deploying K3s. So now we can check the progress here. You see the time going fast here because I had to accelerate that quite a lot. And then you see Fleet deploying all the bundles here in the continuous delivery menu. So you see that we have two deployments here because we already have one for store 1, 2, 3, 4, and we had the second one. Now we can check the web page of the proxy. We have it. It's ready. Now, one of the good things that we have with Fleet and Elemental is, what if I want to add new machines to my cluster? That is possible.
And this would create resilience
Yes,
and
this will
scale
create
to the
resilience.
proxy, right?
Yes, this is it. So now we'll edit the definition. We need to change the quantity here in the machine pools to 3, because 2 is not possible for a Kubernetes cluster. And we add the new serial IDs in the selector. So I will add a number 2 and number 3. Save it. And you see the labels here that are used by Fleet. Apply again. So we'll see in the user interface elemental clusters. So we have only one of 3 machines in our cluster. So we need to add the 2 missing ones. Okay, let's create them. Accelerated, of course. So it's basically the same thing that what happened in the first for the first one.
And we use the same ISO file?
It's the same ISO file. And it's the same ISO file that was also used for the first store. Everything is configured with the proxy labels. So there is one thing to note, is that the Uni proxy, the SUSE Manager Proxy, can only run one instance at a time for now. It cannot be scaled to multiple instances. So what you will achieve with having multiple nodes here on the cluster is that if the node running this pod dies, then Kubernetes will schedule it automatically on another one. So you have resilience. So I had to accelerate the demo quite a lot because it took 30 minutes for me to run the whole thing from the beginning to the end.
And like any good cooking show, we want to see it coming out of the oven.
Yes. Oh, no, I wanted to next slide and rather than, yes, this is it. So here you have a number of resources available. I totally admit this. It was super fast for the demo, but I couldn't get it too long as well. So you have a lot of links here. The first ones are for each of the bricks that we use, and the last one is about this very demo, explaining in every detail how it works and how to set it up and reproduce it. So feel free to head to it and you get all the details.
And we included, obviously, the product pages for the SUSE
Yes.
products that you need for this. There are a number of SUSE Manager SUSE concessions alongside this one. A nice one about with Cedric on modernizing your apps, on how to bring Uyuni server to Kubernetes. And I'm also a part of a couple of them, SUSE Manager in the public cloud and a roadmap session on on SUSE Manager. So make sure you take advantage of all of these SUSECon sessions, and the digital content will be available to you to play whenever you need to. Thanks again for joining us for today's presentation, and we look forward to seeing you in person at SUSECon sometime in the future.
Right. Thank you for listening and waiting for your feedback.